everyone. Let's solve the question on the board. Functions f and g are defined by f of x. F of x is given to be 3x plus 1 for all real values of x, and g of x is given to be x minus 2 for all real values of x. Write down and simplify an expression for the composite function fg of x. That's A. Find expressions for each of these inverse functions. So we have Roman numeral 1, Roman numeral 2, and Roman numeral 3. Verify that the inverse of composite function fg of x is equals to the inverse of g of inverse of function f of x. Okay. So because we are given f of x, which is equals to 3x plus 1, and g of x, which is equals to x minus 2. Okay, define for all real values of x. A. Now, to write an expression for the composite function, f g of x. First, when we write fg of x, to write composite function fg of x, it means that I'm going to put g of x into f of x as x. So it means that if f of x is 3x plus 1, then this will be 3 parentheses g of x, okay, plus 1. And this will be 3 open square brackets. We have x minus 2, which is g of x, then plus 1. Now, distributing 3 in this case, this will be 3x, because 3 times x, that will be 3x. 3 times minus 2, that's minus 6. Then plus 1. So that the expression for the composite function fg of x will be 3x negative 5. So this is the expression for the composite function fg of x. B. Find expressions for each of these inverse functions. Okay, now to find expressions for the inverse functions, this, and the inverse of the composite function fg of x. All right, so Roman numeral 1. Now, I'm going to write the expression for the inverse of f of x. Okay, so Roman numeral 1. Okay, that will be expression for inverse of f of x. Okay, expression for inverse of f of x. So we are giving f of x to be equals to 3x plus 1, okay, which is same as y equals to 3x plus 1. That is, y is equals to f of x. Now I can swap x and y. Swap x and y, so that this will be x equals to 3y plus 1. Now I'm going to carry this 1 over to the left hand side, so that on the left hand side we're going to have x minus 1 equals to 3y. So dividing both sides by 3, y will be equals to x minus 1 over 3. Now, y is the inverse of function f of x. You know, after x and y, as in after both x and y are, swapped, then we can have that y will be equals to the inverse of function f of x. So in this case, this will be the inverse of function f of x will be x minus 1 over 3. x minus 1 over 3. Roman numeral 2, the inverse of function g of x, okay? An expression for the inverse of function g of x. So in this case, we are giving g of x to be x minus 2. So which means if we swap x for g of x and g of x, then this will be x equals to the inverse of function g of x minus 2. So let's also do it this way. Then now I can carry this 2 over to the left hand side. So that this will be x plus 2 equals to inverse of function g of x. So the inverse of function g of x is equals to x plus 2. Is equals to x plus 2. Roman numeral 3. Inverse of composite function fg of x. Now we have the expression for fg of x to be 3x minus 5. So we have that from fg of x, which is equals to 3x minus 5. Okay, now I'm going to swap this for this. Okay, so if we swap x and composite function fg of x, so now this will now be, that's when we have x, it will become inverse of composite function fg of x. So this will be x equals to 3 multiplied by inverse of composite function fg of x, then minus 5. Now I can carry this over to the left hand side to be plus 5. So we have minus 5 on the right hand side. So when it crosses the bridge of equality sign to the left hand side, it becomes plus 5. And this will be equals to 3 inverse of composite function f of x. So if we divide both sides by 3, this will be inverse of composite function fg of x will be equals to x plus 5 over 3. So this is the inverse of composite function fg of x. Now the last question. Now the question asked is for us to verify that the inverse of composite function fg of x, will it be equals to the inverse of g of inverse of f of x. Now we have the expression for the inverse of composite function fg of x, and that is x plus 5 over 3. So now let me write the expression for this. That is the right hand side. So to verify, we want to verify that inverse of function fg of x is equals to the inverse of g of inverse of f of x. So the first thing out now, so this is, we have the right hand side to be equals to the inverse of g of inverse of function f of x. Now the inverse of function f of x, we have that to be x minus 1 over 3. This is the inverse of function f of x. So let's recall, inverse of function f of x is x minus 1 over 3. Okay, now then also the inverse of function g of x, the inverse of function g of x is x plus 2. So we have x plus 2. So which means to find an expression for the inverse of g of inverse of f of x, so it means I'm going to put the inverse of function f of x into g of x as x. Okay, so that will be, this x will now be the inverse of function f of x, okay, plus 2. And this will be the inverse of function f of x is x minus 1 over 3, then plus 2. Okay, so in this case, this will be over 1. So simplifying this, this will be x minus 1 plus 6. 3 times 2, that's 6. Because the LCM of this will be 3. So we have the expression for the inverse of g of x of inverse of f of x. So that's a composite function as well. So minus 1 plus 6, that will be plus 5. So this will be equals to x plus 5 over 3. So let me write the answer here. Therefore, the composite function inverse of g of inverse of f of x, which is equals to x plus 5 over 3, okay, is equal to the, or is the same, okay, is equal to the expression, for that is the inverse of composite function fg of x. So now I can say this is what? Verified. And we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.